Okay, while we're having the meetings, Marvin, would you circulate around and collect $1 a person for cover our expenses tonight?
It's going to be on restoring early AC power supplies, given by Gary D'Amico, and I think it's going to be very interesting. Okay, Gary.
Well, when I was looking into doing this talk on early AC radios, I started doing a little research. And some of the earliest AC radios, or all the early AC radios, came out in 1927. And later on in 1927. And the reason for that was RCA called on GE and Westinghouse to develop an AC tube. So, later on in 1927, RCA received the UX226, first AC tube, triode tube, which is in this radiola 18, and also the radiola 17, which is actually the first AC radio. And also they had the UX227 detector tube. Now, the 26, the reason I'm mentioning the tubes is because the tubes had to be a little bit different than the O1As. Structurally, the 26 is identical to the O1A, except it has it does not have a thoriated tungsten filament. It has an oxide-coated filament. And the gain is approximately the same. And they found out that the detector would not work with a directly heated filament, so they developed the 27. I think that was also Westinghouse. And a little bit before that, earlier in 27, RCA accepted the 80, which is the basis of the power supply. All these power supplies, whether it was RCA, Atwater, Kent, Philco, any of the early ones, all the capacitors were the same. And almost all the power supplies were identical, really. Inside these capacitor housings, there are potted, if anybody's ever taken these apart, there are potted capacitor blocks. This is an Atwater Kent. So if you ever decide to take one of these apart, they're a little bit of a pain. These were the capacitors, basically, that were in the radiola 18. I have a 17 over here also, which I was also working on. Didn't even realize what it was. I just brought it out up onto the bench, started taking it apart, and found out that by looking at one of the manuals that it came from a radiola 17. So, and this is the capacitor block from it. So this can be replaced. What I've been using is Mylar capacitors. Why? Most of these capacitors in here are usually between 1 microfarad and 3 microfarads, typically. And some of the bypasses may be a half a microfarad. But I've been replacing them all with these Mylar since I've got them and they'll last just about forever. Basically, they're made the same way. This is rolled paper with a Mylar insulation, and this is paper wetted with oil, foil in between. And what happens over time, I guess, the wax and aging, they deteriorate. These all read, they're not dead short of it, they're around 200 kiloohms. So they're all, I wouldn't even venture to try one. This is from an Atwater Kent. It's got the date on here, May 29, 1929. That's from an AK-55. Basically, they're the same. Different color waxes. I don't know why they did that. This is from a Philco. They use the black pitch. Anybody worked on early Philcos? No, that's a real joy. When checking out some of these power supplies, if you're brave enough to turn one on without doing any testing, I do a few things. I usually don't do that, having some disasters. I left my Variac in the car. You could use a Variac, bring up the voltage very slow, see if you have any problems. Also, I kind of whipped up something real quick. It looks kind of silly, but I'll tell you what it does. This is kind of like a ballast tube in series with the primary. Also, your radio has a dead short, you plug into this light bulb will light extremely bright, the normal brightness. And that's one way to test it out and see if it has a short. Also, if the radio is over voltage, you can use it as a cheap ballast tube, and it works actually quite well. The reason I use a three-way bulb is so I can get 3 current settings. Actually, this power supply has some problems. The radio does work. It's probably not on. That's the first setting, the 50-watt setting. And since the current to the 50-watt is very low, it's on the order of a couple hundred milliamps. That's good for checking the power supply out. If you just want to plug a radio in general, the higher the wattage the radio draws, of course, the brighter it is. I'll just give a demonstration quickly of what will happen. Say you had a shorted winding in the secondary on the filament, or even on the high voltage secondary. I'll just do this temporarily. I'll show you exactly what happens to the light bulb. As a dead short, the dead short reflects back on the front primary and causes the reactance to be a lot lower, and the bulb gets a lot brighter. So that's just a cheap and dirty way to make it. I've been using this on the 3rd setting. Actually, I should turn this thing off. I'm on the speaker hooked up. And also, what I've also been using too, you can use, I went and got a Radio Shack clip-on ammeter years ago, and you could just use that in the radio with your Variac, or just all by itself. And this radio only draws about 350 milliamps on the primary. So I have to put it on a ×10 and just, divide it by 10 to figure out what your current is. And if you get a rough idea what your primary current is, you know your power supply is basically okay. One of the problems with this power supply is I think I have a leakage current on the primary. If I ground it, I draw a big arc. If I reversed it, it's okay. There are no capacitors on this power supply, so there should be no reason for that. Internally, you can see where I rebuilt the capacitor block using a milder capacitor. It's a little difficult. And some really unique problems. It always seems like it always happens. I didn't have a cloth original. I had to put this rubber lead on. You see these black strips are the resistors for the power supply. This is the higher voltage dropping resistor. And these are the filament center taps. All the AC tubes that are directly heated had to have a center tap in order to reduce the hump. Bring the center of the filament to ground. This one had an open on the center tap for the 71A. When I first turned it on, I was getting reverse bias. I couldn't quite figure that one out. And it wound out that it was open, so I had to put a 1,000 ohm resistor at about 10 watts. There were no resistance values in any of the manuals that I had, whether it was Ryder's or it was the Bateman's. So I had to figure that out, and it worked out quite fine. And most of the time, one of those resistors is going to be open, almost 9 times out of 10. Besides the capacitor block being usually shorted. These capacitors weren't as shorted as other ones I've come across, so I think some of the Philcos are usually in worse shape. But since RCA, since I had a radio, I figured I'd try it out on this first, as far as the flow goes. So, any questions?
Can you discuss the reasons why the NJARC needed the...
Okay, no, I didn't. Kind of rushed over that. Well, the directly heated, I guess because of the electrostatic field from the filament, it's kind of like capacitance to the tube, and it was picking up the 60 hertz from as a detector, because it's a grid-lead detector. They couldn't get away from that even with the center tap, so they made it directly heated. And it started out as a UX225, and I think they upgraded it to like a 227, 227, and literally there was no one was indirectly heated. So that's why they did that. The other reason these capacitors look so big is these are only 1 or 2 microfarads. And the reason the radios are so large, or so heavy, is the chokes inside have to be very large in inductance to give you the right reactance, a lower reactance to 120 hertz, which happens when you use a full-wave rectifier. So that's why these things are so capacity-wise so small, but physically so much larger. I was going to bring one of the wet electrolytics that came in around 33, I believe, but I forgot it. And that kind of drastically changed everything because they went from 8 to 16 microfarads, which would completely eliminate this type of filter capacity. Any other questions?
Voltage that they're going at, 350
No. See, this particular radio, plate voltage is 90 volts with respect to center tap of the 71A. Unloaded, this is 400 volts. This is very high. Still have to drop this down. I'm 30 volts over what it should be. And there's also a switch goes from 120 to 110, and that's set at 120. So the voltage is high, but the filament voltage is a little bit low. So I'm using a DVM using 20,000 ohm per voltmeter. I can't imagine any more than 10%, but I guess that's the particular windings that they had on these transformers. They're probably all a little bit different. But the radio works. Not particularly well, but it does work as an early TRF. They chinched up a little bit on the RF stages, and I guess it's because it was one of the first power supplies. But basically, they're all same up to about 30, 31. They're all basically made about the same way.
How do you align these things? I know 17, I've never seen any
There's no alignment.
adjustments.
There's no alignment. There's no pattern capacitors. And you're certainly not going to bend those big brass plates. Now, actually, the RF design, they put feedback they put feedback into the coils for visualization. They didn't need patterns on there to compensate for antenna loading on the first RF. So, put an antenna on this, you'll get WR in 2 spots. That's typical. So,
Does that 18 have rheostats and power supply?
no, it does not. They eliminated, they put the fixed ones in there. I was able to reduce the hum on this a little bit by going across one of the center taps of the audio tube, the 71 with like a 20 microfarad capacitor ground. That eliminated all the hum you normally hear on AC sets. I don't know if that's going to stay in there or not, but I was just experimenting around and found out that worked out quite well. And
I got some RTA books, as the early schematic. Did you check those for the values for the part?
no, I didn't have the RCA
You
books.
said 17, it should be.
Yeah, it's funny, they didn't list those. List the capacitance, they didn't list any resistance, so you had to kind of figure those out, current wise and voltage drop.
You know, these books were printed later, but they went all the way back to the 28 or 2011.
Okay. Yeah, RC did a lot of development back then, 25, 26, and 27.
Maybe they're being
Yeah, maybe the early stuff would be, yeah. I don't know why they didn't put them in. It would have been, I have a resistor, the drop-in resistor on the 17, and it's open. The way that 17 is made, you could use that as a B+ supply for any of your battery sets that has 45 volts, it has, I think 22 volts, and it has 90 volts. So when I don't have a 17, but when I finally get that back together, I'm going to use that as a power supply to the B+ for a battery set, and it'll work fine. Just make a 6-volt supply. So that's what I'm going to use that for, and that should work out quite well.
Some of these transformers, maybe they all have electrostatic shield between the primary and the secondaries.
I didn't see any evidence of another wire coming out that's electrostatic shield. No.
Sometime, it was a long time ago, I thought I took one apart and I thought there was a shield wrapping the top of it. They had that ground to the core.
Well, that would explain why this is hot on one side. Maybe there's leakage there. It could be. I'm not saying it isn't. It could be. I'm surprised they went to that expense, actually.
Yeah, I wondered whether that was the reduced hum. I don't know why they did that, or just radio interference.
Well, these sets are very susceptible to any AC line noise. It's bad.
Must be just to reduce the line.
Yeah, I mean, there's no capacitors across the AC on either side of the ground at all. And that's one thing about this particular set. It's very noisy, but it does work. Try a little more time, I can probably string them back. And it does work, but it's not great. I've another TRF I have is 87 Philco years ago. And it had the same tube complement except the outputs were 45s. And Very good radio compared to this. Then again, it had adjustable batteries on it, so you can neutralize it. In fact, that was a Nutridyne instead of pure TRF.
Is that a TRF?
This is a TRF. But as each coil has windings on it to reduce feedback to cancel out the oscillations. So that they did great on that. Spent a lot of money on those coils, but they put new patterns on each on the main capacitor. So
What model was it like that looks like that? It's a superhead.
no, this is a TRF. This is
I think
18.
it's 60, I think.
Oh, 60 was a superhead. Yeah.
It doesn't really look too much like that.
No, they use the same boxes. They probably, I don't know if they use the same supplies or not.
More like a casket.
They use the same supply?
Very similar.
Yeah. They're very, well, the chassis is identical. Probably the transformer is identical, but the capacitors are slightly larger. They're 3.5 microfarad versus one by these. So, any other questions? No. I didn't get that. I just realized that last night, as a matter of fact. I was kind of surprised to see that.
You have access to a high frequency.
Yeah. And I'm sure it's on the primary side where the leakage is, you know. But the hum isn't really that bad. There's no hum modulation as if there was leakage like from the cathode to the heater or on the power supply itself. The power supply is relatively clean, so that's strictly probably on the primary side. Okay.
Why? Should we drink Absolute?
Huh?
Drink Absolute?
Les Paul. I saw Les Paul in New York. Oh, he's his little club. Well, back
What a motley crew.
He's still married to Mary Ford. He died.